Okay, so isomerism. So isomer is actually compound that have same molecular formula but different arrangement of atom, different structural formula. So isomerism can be divided into constitutional isomerism, also known as structural isomerism, and stereoisomerism. We look at constitutional isomerism first. So constitutional isomerism divided into three types: chain, functional group, and positional. So we looked at one first. So functional group isomerism, same molecular formula, but I can draw two different structural formula with different functional group. For this one, C5H10, so the general molecular formula is CnH2n. So for CnH2n, you can draw alkene and you can draw cycloalkene. So for example, if I draw alkene, so alkene functional group is carbon-carbon double bond. So here I have 5 carbon. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this alkene has 5 carbon and 10 hydrogen. So I can draw another structure which is cycloalkene, different functional group. So here I also have 5 carbon. 1, 2, 3, 4, 5 and 10 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for CnH2n, I can draw alkene and I can also draw cycloalkene. So both of them have different functional group. Next is Cn. CnH2n plus 2O. So for this one, I can draw alcohol and also ether. Okay. So CH3, CH2, OH. So there are 2 carbon and 6 hydrogen, 1 oxygen. And then I can also draw as ether. Okay, so the first one is alcohol with the hydroxyl group. The second one is ether with alkoxy group. Okay, next is CnH2nO. So this one is aldehyde and ketone. So I can draw this one as aldehyde. So aldehyde has carbonyl compound attached to one hydrogen, and then I can draw this one as ketone. Okay, so both of them have same functional group, which is carbonyl, but they have different class of compound. This is aldehyde and this is ketone. Aldehyde and ketone can undergo a different reaction. Okay, and then the last one is CnH2n and then O2. So this one is carboxylic acid and ester. So I can draw this one as carboxylic acid. Okay, or I can draw this one as an ester. Okay, so same molecular formula, different functional group. Okay, next we look at chain or skeletal isomerism. Okay, so for chain, they belong to the same functional group, belong to the same class of compound. Okay, so for example here, this one is alkane, so this one is CnH2n plus 2. from this molecular formula, I can draw 3 different chain isomer. But this chain isomer belong to the same class of compound. Okay, so for the first one, I can draw as pentane. Okay, there are 5 carbon. Okay, so this is pentane. So I can next with the same molecular formula, I can draw this one, okay, as butane. Okay, so the longest carbon chain here is 4 carbon, which is butane. So this one, we call it as side chain, or we call it as branch. And then another name is substituent. Okay, so this one, so the name for this one is pentane, and then the name of this one is 2-methyl butane. So pentane and 2-methyl butane both have same molecular formula but different structure. Okay, even though they belong to the same homologous series, but they have different characteristic. Okay, and then this one, the longest carbon chain is 3 carbon. Okay, so at carbon number 2, I add on 2 branches. Okay, so we still use 5 carbon, we still use 12 hydrogen, but this one got different name. Okay, the longest carbon chain is here. Okay, so the name for this one is 2,2-dimethyl propane. Okay, so this pentane, 2-methyl butane and 2,2-dimethyl propane, these compounds exhibit chain isomer. They have different longest carbon chain. Okay, and then the last one for constitutional isomerism is positional isomerism. So positional isomerism, they have same carbon skeletal, same longest carbon chain, but differ in position. Okay, however, aldehyde, alkane, carboxylic acid, and amide don't undergo positional isomerism. Okay, because aldehyde, carboxylic acid, and amide, these 3 class of compound, the position of the functional group must be at the end. Okay, so that's why they cannot exhibit, because you cannot move the position of the functional group. For alkane, because alkane do not have any functional group, so that's why you cannot move the functional group. Okay, so for example here I have C3H7Br, so I can place Br at the first carbon. So Br in the position 1. So we call this one as 1-bromopropane. Okay, and then I move the position of Br to the second carbon. So for this one, the name will be 2-bromopropane. Okay, the position of the functional group, okay, is different. Okay, but then it's still at the same longest carbon chain, which is propane, but the position of the functional group is in different position. So this one we call it as positional isomerism.